All right, tomorrow are just the notes on capacity and volume. But before you go into these, I wouldn't worry about fluency tomorrow, but I would take time to do some connections between your system. So on a blank sheet of paper or whatever, I'd ask the kids, okay, before we start, I want to test your knowledge of what we talked about last week. Which system is the United States? Which system is us, the United States? Hopefully your kids can tell you customary. The customary is us, the United States. All right, and then say, okay, well, pull out your star charts from the desk or whatever. What are, and all right, and we talked about, by the way, customary length, width, and height. So one of the units is the inch. Can y'all show me an inch? Good, everyone showed me an inch. All right, so we've got inches. Now, what's the other system? The other system is the metric. Actually, I'm going to rewind. Sorry. Inches, show me an inch. All right, inches, good. All right, 12 inches build into what? And y'all can look at your star chart. That's right, 12 inches makes a foot. What is something I can take in this classroom to show a foot? Yes, a ruler, because if y'all have watched the videos, then that would be the thing we're kind of building on. So show the inch, 12 inches is a foot, then ask them, what can I grab? A ruler. All right, well, what is next? How many, we know that 3 feet build a what? A yard. All right, well, y'all said 1 foot is a ruler. So a yard, can y'all, and before this you might ask them, can y'all show me 1 yard? And this is when they're supposed to open up their arms wide. And we talk about estimating, but yeah, a yard stick. 3 feet make a yardstick, which is like having 3 rulers. And we said 1 ruler is a foot, which is 12 inches. So that would be 12 plus 12 plus 12, which is 36 inches. Good. All right. And then 1,760 yards builds what unit? The mile. Okay, well, miles. Those would have to be 1,760 kids in a line. So if you walk for 25 minutes or ride a bike for 25 minutes, it has to be a long walk or a long distance to hit miles. A long hallway is not miles. Going down one side of the school, like walking down from the front of the school to the playground, one side of the street is not a mile. Heck, 1 lap is barely a mile around the whole school. So just talk about that. All right, so this is us. These are the units we would use for length, width, and height. All right, well, metric. Metric is the other system. So if this is us, why are we having to learn the metric system? And that's when you tie in, well, science around the world is metric. So we have to use the metric system. So how do we know that units are metric units would be a big question. How do I know I'm looking at a length, width, or height metric unit? What's special about metric units? And you might have to, if they're struggling, say, look at the star chart. Look at each of the words. You've got millimeter, you've got centimeter, you've got meter, you've got kilometer. What is unique about metric units? And hopefully they finally say meter. Metric units say meter. Metric meters. All right, so starting there, what's the smallest unit? The millimeter. And if you're crazy like me, you'll pull an eyelash and go, yep, there's a millimeter right there with some mascara. Look at that little clump of mascara. That's pretty. There's a millimeter. Itty bitty bitty. All right, well, on your star charts, it says that 10 millimeters build 1 centimeter. Can y'all show me a centimeter? Hopefully they show you the pinky now. Centimeter. Yep. Where can we find centimeters? On a ruler. That's right. Centimeters are on a ruler, which makes the inch and the centimeter, BFFs. If you're measuring this remote in my math class, you're using your inches. But if you're measuring this remote in anywhere else in the world, or you're measuring it in science, then you're using centimeters. All right, well, so itty bitty millimeters, 1 centimeter. 100 centimeters, 100 cents makes $1. 100 centimeters make a meter. Can y'all show me what a meter looks like? Hopefully, once again, they open their arms up wide. And you're like, yep, a meter is a meter stick. Well, which one of our units is a stick? Yeah, yard. Yardstick, meter stick. These guys are BFFs. They don't hang out at the movies. They're not those kind of BFFs, but they are close to the same size. If I'm measuring the length of a door in yards in our system, then in science class, I'm measuring the length of the door in meters. So that's the connection, is that they need to, if they can make these connections, then you know that you're really getting across to them measurement units. And this is when I learned that kids are really good, not at converting, but at talking about the right size. Inches, centimeters, they're both on a ruler. Yardstick, meter stick. There's no one that's a millimeter BFF to ours. And we have a foot, they would have a decimeter, which we don't use in 4th grade. All right, well then 1,000 meters makes what? Well, the star chart tells us it makes a kilometer. Well, kilometers, 1,000 meter sticks, that sounds like a long distance. So who's a long distance in ours? Yeah, the mile. So miles and kilometers, kilometers, these are BFFs. If I'm going to measure a highway in miles in the United States, everywhere else is using kilometers. Take time to do this. It took me 7 minutes. It'll take you a little bit longer with the kids, but this is vital. And if you walk in a classroom and the kids can't tell you who's the BFF of this or who in this system or that system, then you can almost bet that when they get those questions like, what would be the length of a cat, it can trip them up, because they might know mile really well, but this one is weird. Well, I always told the kids when I was teaching math, every time I see kilometer, I immediately think mile. That's what I think, because that helps me. And then I would take time to sing the little song. Millimeter, the itty bitty squish space. Centimeter, so they should be pointing up and down on their pinky nail. Decimeter, we're not done. Then there's meter, open up your arms. Kilometer, and you're pointing down the highway. Hey, 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 aren't metrics fun? If you sing that a few times, it's amazing how much it sticks. Then move into capacity and volume. And I would tell the students, all right, I want y'all to say the word capacity. Say it again, because if we can't say it, we sure aren't going to write it. Capacity. A cap. How much can we fill in the cap? Capacity and volume, these are pictures of it. It can be dry, like dry cereal, or it could be liquid. But in this case, in math, these units are all going to be liquid units. And capacity and volume just means how much space is inside an object, I guess. I should put it that way. How much space can fit inside an object? And actually, I think now that I'm saying that, when I'm teaching this, after we say it a few times and after I point out, volume can be dry or liquid, but in this case, it's all liquid stuff. What I'm really thinking of is, like, I might use it. For example, you might hear me say, what's the capacity of the bathtub? What is the volume of the kitchen sink? What is the capacity of the measuring cup? What is the volume of the bowl? All we're asking is how much can fit inside them. So capacity and volume is how much space how much, I don't know. See, and now I feel like I can't word it. What is the capacity of the bowel? All right, there we go. That's what I always wrote. How much it can hold. Ha-ha. Capacity and volume are how much an object can hold inside of it. So like if I ask you what the capacity of this container is, all I'm saying is how much can this container hold of cereal? If I say, hey, what's the volume of that cube? All I'm asking you is how much can it hold inside of it? So think about a tissue box. That's a dry good, and you can do volume. You can say how much space is inside of that tissue box. That's volume. But again, all of our measurements are liquid ones, and I don't think I brought my star chart, so that's a bummer. We're going to focus on the customary. Customary, remember, is us as in the United States, and we're going to write that. And it needs to be capitalized. It's a proper noun. It's the name of our country. And then I'd get up to make sure that they did this part, that, maybe they starred this. Get up and, check. Are they doing what you're teaching? All right, well, these are the units for volume. So we're going to draw some liquid drops around these because I want y'all to realize that these units have nothing to do with how long it is or how tall it is or how wide. This is how much it can hold in a liquid. How much is the capacity? So these are liquid units. And what I would do on my star chart, let me have a fake star chart here. So right now on y'all star charts, time should be starred, meaning we've taught time. And then we have that length, width, height section starred. Well, right here in the middle, I think it says capacity. I don't know if it says volume. I can't remember. Well, I would star that section. And these are the customary ones right here. And then you're going to have your metric over here. Well, customary is going to have the 1 gallon is the 4 quarts. And 1 quart is 2 pints, and 1 pint is 2 cups, and the 1 cup is the 8 FL ounces. So you're going to have that. So these are our customary units. So what I would do is I would say, okay, well, we're going to put a star by capacity. So after I'm sorry, I'm jumping around, but after we said it, we define, I used it in sentences. Use it in sentences because that's what really helps them. What's the capacity of the bathtub? What is the volume of the tissue box? How much can it hold? Then I would make them go to their star chart and write the same. So right here by capacity, I think we usually just put a little arrow right underneath, and we'd write how much an object can hold. What is that? I think it's Landon pouting. How much an object can hold, and then of what? What specifically? Well, we're not talking about solids. We're going to be talking about liquids. So around all these units on your star charts, I want you to draw little drops because I want you to remember that this section, and go ahead and draw them over here by the metric, this section is liquids. Because up here we wrote length, width, and height. Well, I want them to understand that this section is my liquid unit. That way when they see how much an object can hold, they understand this is the liquid. And that definitely is a checking time. All right, well, these are our United States units. So let's look at the sizes. You've got ounces. And on your star chart, I would look and say, okay, it says 8 FL ounces equal 1 cup. It says it on the star chart. FL means fluid, and I, of course, am going to have to act like a hippie, so I always, tell them, liquids, they're fluid, they're peaceful, they flow. So fluid means liquid ounces. 8 ounces, well, like a shot. A shot that you get at the doctor's office, it's ounces, it's a small amount. If you grab objects in the classroom, I always pull them up on the overhead, so look. This is 4 and 25 hundredth. Make them read it out loud. There's your mixed decimal. fluid ounces. So you show them. So this, and it's liquid in here, it's 4 ounces. Well, 8 ounces is a cup. 4 is half of 8. So this is only half of a cup if I poured this. So the problem is, and this is what I tell kids, here's what, I'm like, hand me my cup. Dude, that is so not the size of a cup. This would be closer to the size of a cup. I tell them think of like a coffee cup, and not the monster ones that we like, just a regular like tea cup. You could be British. Oh, have some tea. Of course, I can't speak that, so.
Terrible accent.
Yeah, it is a terrible accent. This could be close to a cup. Tell them measuring cups. So talk about it a second. All right, well then, I read on my star chart that a pint is the same thing as 2 cups. So 1 pint equals 2 cups. That's what the star chart says. Well, I always tell kids, think of the ice cream cartons. Like if you've ever gone to the store and you've bought your own ice cream carton, that would be a pint. And here's my problem, and I mean, I'm honest with the kids too. I get confused because these are so close together in size. It's really hard to, I hate it if they want to make me choose between these. Usually they don't. Because to me, this one's obvious. Quart gets pretty obvious. If it's really big, I go to gallon. It's these right here that get confusing. You also could say cups are like the yogurts at the cafeteria. In fact, the cafeteria milk says half a pint. Well, if you're half a pint, half of 2 is 1. So half your cafeteria milk cartons are a cup. So then it tells me on my star chart that 1 quart is the same as 2 pints. So you get 2 of these ice cream cartons and you've got a pint. Now, I always tell the kids, when I think of quarts, I think of when I buy chocolate milk or orange juice or an apple juice. When you buy them in those paper cartons, those tall, skinny cartons, that's where you're getting into a quart. A lot of kids will tell me, like, my mom's coffee creamer or something. Yes, that's true. Then water bottles. I like to look around because usually kids have water bottles. If you get like the Aquafina or something, you're right here in the cup. Like Aquafinas are a lot of times like 8 or 12 ounces, so you're somewhere in here. But I tell them quarts, you would have to have smart water. Like if you went and got those tall, skinny smart water bottles, and see in my room I had it on one of those hanging mobiles. I don't think it's there anymore, but smart water, that tall, skinny one, that would be a quart. These Yeti cups, here you go. Now you're getting into a quart. This is about the size of a quart. So it's not just fly through this. It's talk about some different objects that they can relate to. Gatorade. You get a small Gatorade, you're right here in the pint zone. But you get those big, fat, round cylinders, that's the quarts. And then gallons are really easy for kids. They understand the size of a gallon because we think a gallon of milk. So I would just write 4 quarts. All right, so now we're going to reason on some of these. Like let's reason. So this eyedropper, like if you squeeze, these are the things that squeeze in our eye. So it says less than a cup, 1 cup. Well, let's look up here. Do you think you squeeze 1 full coffee cup of liquid into your eyeball? No. You're going to squeeze 3 gallons worth of liquid into your eye? Well, no. Now you're drowning and can't breathe. And if you're not going to use a cup, you're sure not going to use a pint. So obviously the eyedropper is less than a cup. It's ounces. It's like a little bitty shot. Or if you were going to fill up a spoon. That one was easy. Gas tanks in cars. This one might be a little more hard for kids. Now here's where they get tricky. And this is what... So 3 quarts. 3 quarts. Well, let's see. 1 quart is one of these milk cartons. Well, let's look at gallon. What does gallon say? 4 quarts. Well, how many quarts are here? 3. So is this even a gallon? No. Do you think a car tank of gas is less than a milk jug in there in your car? No, that one's bad. Well, then they get you here. And I think at this point, honestly, looking at this, I would say we're going to hold on this until we do the big G. Water for a house plant. Same thing. I think, all right, we're going to time out. That one's easy. Before we do these, we're going to do this big G, and then we're going to finish this. So here's the great thing. Big G, You know how we've been converting the metric units and all that, how we use the T-charts to put inches and feet, and 1 foot is 12, and every time I add 1 here, I have to add 12 over here. Well, we can cheat with the customary, and we're going to make a big G. And you use your star chart. Your star chart says 1 G has 4 quarts in it. So 1 gallon has 4 quarts. So we're going to draw 4 large Q's. And the larger you draw the Q's, the better. So 1 big gallon has 4 quarts in it. It takes 4 of these to build your gallon. All right, well, if you look at the star chart's next going to say 1 quart is 2 pints. So 1 Q has 2 pints in it. So 1 quart, 1 Q has 2 pints. And this is when my humor comes in, and I'm like, a quart has pee-pee in it. And then they're like, what? Is she really saying that? Yep, talking about pee-pee. So 1 Q, 1 quart is made of 2 pints. 1 quart, 2 pints. So every Q has 2 P's in it. The Q's have pee-pee in them. And they laugh, but then they remember that stuff. And then use that. Well, the star chart says 1 pint has 2 cups. Well, what are these P's standing for? Pints. 1 pint has 2 cups. 1 pint, 2 cups. So we're going to fill in every pint with cups. Which is why you tell them you want to write as big as you can. Then it tells me that 1 cup has 8 fluid ounces. So at this point, it's really hard to fit in stuff, but I always had the kids like find a C, like one of these, and say, like do an arrow and put 8 ounces. And do it on like a couple of them. 1 cup holds 8 ounces. So kind of like that. I mean, I guess you could do little bitty 8s around, like 8, 8. But then that gets insane to me. All right, once you make big G, conversions are done for you. So, for example, we're going to go back up here. 4 pints. Pint starts with P, so find 4 P's. Like 1, 2, 3, 4. Do y'all see that on mine? So 4 pints. How many quarts do you see? How many Q's are there? 2. 4 pints is 2 quarts. Well, 4 quarts is a gallon. So if I'm only talking about 2 of them, I'm only talking about half. Well, we said that this was not good. Well, this isn't either. 16 cups. Sounds like a lot. Well, 2, 4 cups are C's, right? 2, 4, 6, 8, 10, 12, 14, 16. 16 cups is 1 gallon. Right here in 1 gallon of milk are 16 cups. So the cars hold 15 gallons. That makes sense. Water for a plant. A house plant. Well, first of all, which of these units is not a liquid unit? Pounds. Yeah, that does not belong. So does your household plant. Like, there's one of mine right there. See? Are we going to fill my household plant with 3 gallons of water? No, it's going to be flowing out everywhere. Quarts. Quarts don't look as bad. 6 quarts. Well, let's look back at the gallon. How many Q's, how many quarts are in a gallon? 4. So, if I grabbed a second gallon and put quarts in them again, we're talking about 6 quarts. So 1, 2, 3, 4, 5, 6 Q's. So we're talking about 1.5 gallons. Again, do you think you want to pour a full gallon and another half gallon into my plant? Or 2 cups, which is a pint. So like that ice cream size, or like this size of water. I mean, which do you think is most reasonable? I mean, I'm going to lean toward the cups because, I mean, if I'm watering my plant weekly, then that should be enough. Huh. And honestly, actually, my husband kind of giggled if you heard that, but that's true. And sometimes I don't feed Ivan over there. I don't give Ivan any water but every 2 weeks, and look at him, he's happy. IVs are easy. And I actually grab water bottles and I just pour a water bottle in, which is definitely the pint. Sand in a pail, a bucket. So I tell them, think of a sand bucket. 32 gallons seems a little bit excessive. And I'm telling y'all this, but see, if it were the kids, I'd say, are there any that we could get rid of? Yes, 32 gallons. 32 gallons of milk are not going to fit. Is there any other that you think are ridiculous? Well, and I honestly think 2 others are ridiculous. Yeah, a cup, I agree. 1 cup is not going to fill up my sand bucket. And if you get rid of the cup, you have to get rid of ounces because 8 ounces build a cup. A gallon, yeah, I would agree that a sand bucket is close to the same size as a gallon. All right, this goes really fast with the big G. I want to know how many cups are in 16 ounces. Well, let's look. What's 8 plus 8, y'all? And the kids will say 16. Good. How many C's is that? So I'm going to block everything else out because here's the 8 ounces. And that comes off of 1, 2 C's. So these 16 ounces are 2 cups. You're not having to use a T-chart. You're not having to multiply. You're not having to repeatedly add. You get to just cheat off big G. How many cups are in 8 pints? Well, you got to go find 8 pints. 8 P's. 2, 4, 6, 8 P's, right? So it's all of the P's here. How many C's, how many cups are in the pints? So I want y'all to think on your own. How many C's are in all these pints? And then when you see most kids' hand raised, say, all right, at the same time, how many? Hopefully you hear 16. And I'd say, all right, well, I want all 2, 4, 6, 8 pints. How many cups? Well, that's 2, 4, 6, 8, 10, 12, 14, 16. So even after I hear them answer, I model. That way the kid who's not understanding gets to see it. How many ounces are in 3 cups? Well, we said 2 cups is 16 ounces. So I have 3 cups. 1, 2, 3. And I know every C holds 8. So 3 groups of 8 is 24 ounces. How many pints are in 7 quarts? Well, we need to go find 7 Q's. Well, how many Q's are here? 4. So what do you think you should do? Well, usually kids say, well, you could count them twice. I could. What else could I do? I could draw it again. Well, we already drew it. So we have 4 here, and we want 5, 6, 7. And we want to know how many P's are in the Q's. Well, 1 Q has 2 P's, so I'm going to go out over here, PP. Wahaha. So in 1, 2, 3, 4, 5, 6, 7 Q's, there are 2, 4, 6, 8, 10, 12, 14 pints. Now, I have done a lot with them. At this point, I'm going to be like, you know, you could ask them, but I mean, as long as you're guiding, not telling, but asking. I would ask the kids, what do I need to go find first? 10 pints. Okay, well, what are pints? The P's. Okay, so I need to find 10 P's. 2, 4, 6, 8, 10. And what am I looking for? How many Q's is that? Okay, well, 2 pints, that's 1. So here's 2. What am I looking at? Now I'm lost. 10 pints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pints. That's 1, 2, 3, 4, 5 Q's. How many quarts is a half of a gallon? Well, here's the big G. If you cut it in half, hi-yo! How many quarts are there? 2. And then these 5 quarts. Well, right here, we said 5 quarts was 10 pints. 10 plus 4 makes 14 pints. 5 gallons equals how many quarts? 5 G's. 5 gallons. Well, 1 gallon has how many quarts? 4. So every gallon holds 4 Q's. So we have 5 groups of 4, which is 20. plus 3, which is 23. Easy peasy. And then you have your word problems. And these are where I do a lot of drawing. So we want to know, does Kylie have enough milk for recipe? And these are ones where I tell the kids the explanation is easy. That's your work. But what kids forget, they're real good about showing their work, but they never answer, does she have enough? If I asked you, do you have enough milk? That's a yes or no answer. So, well, what is Kylie saying? Or what does Kylie have? Kylie has 1 quart of milk in the fridge. So she has 1 Q. That's what Kylie has. What does she need? It needs 4 cups. Well, quarts. Look at our star charts. 1 quart has 2 pints. But the recipe's calling for cups. 1 pint has 2 cups. 1 pint has 2 cups. Does she have enough? Well, how many cups are in the quart? 1, 2, 3, 4. So 4 cups is what the recipe wants. She has a quart. Does she have enough? Yes. How do I know? Because 1 quart is the same thing as 4 cups. 1 quart has 2 pints, or 1 quart has 1, 2, 3, 4 cups. So drawings. This one's about Ashley, and we want to know how many ounces of milk she buys in all. Well, I would ask the kids, if you want all of the milk, do we need a whole number or a part of a number? All means you need the whole amount. So if you want a whole amount, do you get big or small? Big. Are there any words to represent some grouping? Yep, each. Each is a grouping word. You either group all together or you group separate. Well, bam, bam, multiply. Why are word problems hard, guys? Because they're words. What can we do to make it easier? Draw. What could I draw? 3 gallons. I agree. Ashley has 3 gallons of milk. Each gallon contains 128 ounces. So this one has 128 fluid ounces, each one. How much does she have in all? Well, what do y'all see? I see repeated addition. How many times? 3. So 3 groups of 128. Work it out. I want cups of milk equivalent to total fluid ounces. Oh, so up here. So I want to know how many cups, EQUAL, are equivalent to this total. So now I have to work it out. 6, 7, 8. So how many cups are equivalent to all of the fluid ounces? Good Jesus, what was I thinking, y'all? Let's see. This is when I would go to a T-chart because it's such a large number. We need cups. We're dealing with cups and ounces. And our star chart tells us 1 cup has 8. 1 cup has 8. And every time I add 1 cup, I must add 8 on the other side because every 1 cup adds 8 over here. So you add 1 cup, you add 8. You add another cup, you add another 8. So add another cup, that adds another 8. And if they know their multiplication, this is really fast. All right, we need ounces. So if we look, if I plugged in ounces over here, I need to figure out the cups, right? So let's find a pattern because I sure don't want to fill out a T-chart like this. So we have to move from our ounce to cups. So look, ounces to cups, ounces to cups. Our numbers getting bigger or smaller? They're getting smaller. Well, how do we get small in math? We either divide or subtract. Well, if you're repeatedly counting by 8s, repeated addition is multiplication. So that means the opposite is divide. And you could show them 1 times 8, 8. 2 times 8, 3 times 8. So if one way is multiply. So what you need to do is we'll do 384 split into groups of 8. Because every 8 ounces is going to give us a cup. And then do your division. Viviana has 3 contains of punch. She has 3 contains. She has 3 containers. Well, we're wanting 3 containers all together. So you go through all together is the whole. You got to get big. I'm not seeing really any repeating words. How can I make it easier? I could draw it. So she has 3 containers. So she has 1, 2, 3. 1 has a capacity of 2 quarts. What does that mean? This has a capacity of 2 quarts. And if they look at you with the blank stare, go, well, look at her. Oh, how much can it hold? Oh, so this container has a capacity of 2 quarts. It can hold 2 quarts. This one holds 4 pints. And this one has a volume of 1 gallon. All right, already easier because I can see it. How many quarts of liquid does she have? So I want the quarts of liquid. Well, when you look at these, here's what I noticed. This guy's in quarts. That's not in quarts. That's not in quarts. So what do you do if they're in the wrong unit? You have to convert. Well, what does convert mean, y'all? We have to change. Who can help me make changes? Big G. Which we could have been looking at the whole time, I guess, on mine. So I need to change and convert to quarts, because whatever the question wants is what you do. So 4 pints. Let's go find 4 P's. 4 P's, right? 2, 4. How many Q's is that? 1, 2. All right, so 4 quarts, or 4 pints, 2 quarts. 1 G. 1 G has 4. How many quarts does she have altogether? Well, she has 4 plus 2 plus 2, so she has 8 quarts. It's amazing how these pictures make it. And then blah, 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 Catherine. I want to know cups left split between Catherine, 4 friends. All right, left. If you have leftover food, is that all of it or part of it? Yeah, leftovers are parts. And here's what I know. If I'm splitting up my candy between you and me and you, if I'm splitting it, I'm getting less and less. And if you're splitting, that's division. Because when you split, you want things to be fair. And splitting is sharing. And sharing is fair. So fair share is a big division word. All right, so I know I need to get small, and we're going to divide. So she has a large bucket with a capacity of 500 cups. So I've got this bucket. It's got 500 cups. She pours half of that amount out to paint the outside of her garden shed. So out comes half. How many cups are left? Well, if you chop something in half, hi-ya! How many parts do you chop it into? 2. So how are we going to find half of 500? We're going to have to chop 500 or split 500 into 2. Well, then you're going to go through that process and it's going to end up being 250. Is that the end? Nope. But after that, how many cups are left to split between Catherine and her 4 friends? 250 cups. And some kids may say, well, we need to divide. No, it doesn't say how many do Catherine and her 4 friends receive. It just says how many are left to split. Well, if I pour half out, that half is gone, and I'll be left with 250 cups to split.